Hello everyone, welcome to Easy Ganit. My name is Samir Sardana and in this video, we are going to discuss complete quadrilateral chapter in one single shot. 48 properties of parallelogram, rectangles, rhombus and sphere will be covered in this one single video. This is a completely new way of learning quadrilateral. All the students, sabhi bache, students preparing for CAT and ambient entrance exams, other ambient entrance exams, and students also preparing for government job exam must watch this video. ये एक single ऐसा वीडियो है जो आपके पूरे क्वाड्रिलेटरल की सारी प्रॉपर्टीज को एक ही सिंगल वीडियो में कवर करेगा और कॉम्प्रिहेंसिवली विद प्रूफ ऑल 12 प्रॉपर्टीज विल बी डिस्कस्ड. सो व्हाट वी विल बी डूइंग इज विल राइट डाउन वन प्रॉपर्टी. टोटल 12 प्रॉपर्टीज हमें पैलोग्राम की करनी है, रेक्टेंगल की, रोम्बस की एंड स्क्वायर की. दैट मींस इन टोटल 12 प्रॉपर्टीज फॉर ईच ऑफ दीज फिगर. सो टोटल हमें 48 प्रॉपर्टी इस सिंगल वीडियो के अंदर टारगेट करना है. सो वन बाय वन जाना पड़ेगा? नो. व्हाट आई विल डू इज आई विल राइट डाउन अ प्रॉपर्टी एंड आई विल सी दैट how that property will behave in case of parallelogram, rectangle, rhombus and sphere. So we'll be able to cover 48 properties. A completely new way and you'll enjoy it a lot. And we will be learning all these properties with proof. So आपका पूरा quadrilateral का chapter with basic concept, proof, everything with complete logic will be covered in this one single video. Now before I start with all those 12 properties, so how we are going to approach it. So here I have a slide, right? Parallelogram, rectangle, rhombus and sphere are there. So पहला property है diagonals are equal. So we will see कि diagonals किस figures में equal होते हैं, right? Similarly, there are so many important properties, right? So 12 such properties will be covered in this whole video, guys, right? बहुत अच्छी properties हैं, right? There are so much, there would be many such properties out of these 12 that you must not have studied earlier, right? बहुत ही unique video बनने वाला है ये quadrilateral का, and you will not find any other video comprehensively covering all these four figures in such detailed manner. So what I will do is, first I will discuss the basic definition of parallelogram, rectangle, rhombus and sphere. Because once I understand the basics of parallelogram, rectangle, rhombus and sphere, only then we will be able to see how those 12 properties will behave for each of these figures. I just want all of you to first understand the basics of parallelogram, rectangle, sphere and rhombus, the basic definition. If you understand the basic definition, I promise you all the 12 properties that I'm going to cover, you in this video, you'll be able to understand those concepts so easily. बहुत easy लगेगा आपको, and you'll never forget this. You will never forget all these 12 properties. Now let's start with this, guys. What is a parallelogram? What is the basic definition of a parallelogram? Parallelogram, see guys, parallelogram is a figure. Right? It's a quadrilateral. What is a quadrilateral? It's a four-sided polygon. जो four sides आपस में intersect करती हैं, then the closed space that you will get will be in the shape of quadrilateral. So quadrilateral, in short, is a polygon made of four sides, right? four sides के intersection से जो closed space बनेगा, that would be a quadrilateral. And quadrilateral can be categorized, right? Mainly can be categorized in these four figures, right? Main ये four quadrilateral हमें discuss करने हैं, which are different based on their basic properties, right? What are those basic properties? What is the basic definition of parallelogram? See guys, in a parallelogram, when I talk about a parallelogram have opposite sides parallel and equal. Parallelogram की opposite side जो होंगी वो parallel और equal होंगी. That means if I'm saying that this side is A, then this side will also be A and both of these two sides are parallel. And these two sides will also be parallel and equal. That means if I say this side is B, this length will also be B, and this side will be parallel to this side. So if I name this vertices A, B, C, D, AB is parallel to CD and the length of both of these two figures is same. AD is parallel to BC and length of both of these two figures is, both of these two sides is also same. Okay. So what is a rectangle? Rectangle is also same. Rectangle also has the same property that opposite sides are parallel and equal. So if I name these vertices as A, B, C, D, AB will be same as CD, AB will be parallel to CD, AC will be same as AD, and BC will be same as AD, and BC will be parallel to AD. So if I say this is A, this will also be A, this is B, then this will also be B. Then how these two are different? That these two figures are different in terms of angle. That means here this angle is not 90 degree. If I make the angle between these two adjacent sides as 90 degree, then the figure that I'll be getting will be called as a rectangle, right? This is what I want you to know. The basic definition. So this is the basic definition of parallelogram rectangle that you're supposed to know. Only then those 12 property would be a cakewalk for all of you. तो आप बहुत इजीली उन सारी 12 की 12 प्रॉपर्टीज को समझ जाओगे, राइट? ये एंगल 90 का नहीं होता, इसमें ये एंगल 90 डिग्री का होता है. ये बेसिक रूल्स ही हमें हेल्प करने वाले हैं उन सभी 12 प्रॉपर्टीज को ढंग से स्टडी करने के लिए प्रूफ के साथ, राइट? और आपको बहुत इजी लगेंगी वो 12 प्रॉपर्टीज. ओके, what else? What's main other difference between parallelogram and rectangle? You see that we know that, right? If two sides are parallel, right, then the angle made on the same side of transversal line will have a summation of 180 degree. So if I say that this angle is alpha, this angle is beta, in this case alpha plus beta will be equal to 180 degree. So will this be true here also? Yes. ये 90 है, ये भी 90 है, right? So 90 plus 90 तो 180 होगा ही होगा. But you see that summation of two adjacent angle here, let's say, is alpha plus beta is also 180 degree. But in this case, alpha is also equal to beta. Here, alpha plus beta is 180 degree, but both of these two angles are not same. अगर ये दोनों सेम हो जाएंगे तो फिगर पैरेललोग्राम नहीं होगा, फिर वो रेक्टेंगल बन जाएगा, right? This is a basic thing that you're supposed to know. What is a rhombus then? Rhombus, right? So rhombus have all four sides equal. Rhombus की चारों sides equal होती हैं and opposite sides parallel भी होंगी. That means AB will be parallel to CD and BC will be parallel to AD. So ये दोनों sides parallel भी होंगी and both of these two sides will also be equal, right? Okay. And what is a square? Square के अंदर भी बचो. In square also you will see that opposite sides are parallel and equal. Opposite sides are parallel and equal. Okay, so what is the difference between square and rhombus? इसमें भी opposite sides parallel and equal है, right? In this also you have opposite sides and parallel and equal, and in rhombus also you have opposite sides parallel and equal. So what is the difference between the rhombus and square? The difference between rhombus and square is exactly same as the difference between parallel and rectangle. Parallelogram से जब आप rectangle की तरफ जा रहे हो, so you are making these angles equal to 90 degrees. Similarly, when I'm moving from rhombus to square, I'll have to make all these angles equal to 90 degrees, right? So rhombus में, if I'm saying that this is alpha, this is beta, then alpha plus beta will be equal to 180 degree. That means summation of two adjacent angles will be equal to 180 degree. Summation of these two adjacent angle will be equal to 180 degree, but both of these two angles will not be equal. But in the case of square, summation of two adjacent angle will be equal to 180 degree, but both of these two angles will also be equal. So this will be equal to 90 degree. So that's how you make a square from a rhombus, right? Exactly in the similar way you are making a rectangle from a parallelogram. पैरेललोग्राम से जैसे आप रेक्टेंगल बनाते हो एंगल्स को 90 डिग्री बना के, सिमिलरली स्क्वायर को आप बनाओगे रोम्बस से सभी एंगल्स को 90 डिग्री बना के, राइट? दीज आर द ओनली प्रॉपर्टीज, राइट? ये बेसिक डेफिनेशन है जो आपको माइंड में रखनी है एंड यू विल सी दैट कि सारी की सारी 12 प्रॉपर्टीज आप बहुत इजीली समझ जाओगे इन वन सिंगल शॉट, राइट? सो दीज आर द बेसिक डेफिनेशन. पैरेललोग्राम क्या होता है, रेक्टेंगल क्या होता है, रोम्बस क्या होता है, स्क्वायर क्या होता है. Now let's talk about 12 properties for each. That means total 48 properties in total, right? Ready? Now let's start with the first property, number 1. So here we have this figure. We have a parallelogram, rectangle, rhombus and square. The first property that we are going to talk about is diagonals are equal. Now we just have to see कि diagonals किस figures के equal होते हैं. I'm not saying कि चारों में diagonals equal होते हैं. This is just a property that if I have to find out what are those quadrilaterals where diagonals are equal. So I'll just identify them with proof now. See guys, we have this parallelogram ABCD, right? And basic definition में हमने ये सीखा कि ये दोनों angles का summation would be equal to 180 degree. Alpha plus beta would be 180 degree, right? And beta plus this will also be 180 degree, right? So alpha plus beta is 180 and beta plus this is also 180. So can I say this angle has to be alpha? ये दोनों एंगल का समीशन 180 है, ये दोनों एंगल का भी समीशन 180 होगा because these two lines are parallel. और पैरेलल में ट्रांसवर्सल लाइन के में जो एडजेसेंट में इंटरनल एंगल्स बनते हैं उनका समीशन 180 है. सो दिस इज 180, दिस इज 180, सो दीस टू एंगल्स हैव टू बी इक्वल. सो पैरेललोग्राम में अपोजिट एंगल्स इक्वल होंगे. So if this is beta, this will also be beta. Okay. But दोनों एंगल सेम नहीं होंगे, बिकॉज अगर ये दोनों एंगल्स को सेम किया, अल्फा और बीटा को अगर मैंने सेम किया, देन पैरेललोग्राम विल नॉट बी पैरेललोग्राम, इट विल बी अ रेक्टेंगल. Every rectangle is a parallelogram, but every parallelogram is not a rectangle. क्योंकि पैरेललोग्राम की सारी प्रॉपर्टीज रेक्टेंगल में चलेगी, राइट? क्योंकि इसमें अपोजिट साइड्स पैरेलल एंड इक्वल है, और यहां पे एंगल्स भी इक्वल हो जाएंगे. सो एवरी rectangle is a parallelogram, but every parallelogram is not a rectangle. Okay, so opposite angles will be same in parallelogram. Now, but both of these two angles are not same. Now see that, guys. If I draw a diagonal BD, if I draw the diagonal BD in this figure, this is my diagonal BD, right? Now look at this diagonal BD. Is this diagonal BD same as diagonal AC? Can I say that? Not possible. The reason is alpha and beta are not equal, right? Alpha and beta are not equal. And you see that just for a case, if I'm saying that alpha is a 30-degree angle and beta in that case would be a 150-degree angle, right? So you guys tell me, is it possible that a side which is opposite to 30-degree is same as a side opposite to 150-degree? Because if you look at these two triangles, if you look at the triangle ADB and the triangle ABC, अगर आप triangle ADB और triangle ABC को ध्यान से देखो, then you will see that ये side और ये side same है, ये side दोनों की same हो गई, right? This side and this side is same, this side is common side, right? So can I say that कि ये दोनों sides तो equal हो गई, but alpha is a 30-degree angle, so 30-degree के opposite वाली side और 150-degree के opposite वाली side same नहीं हो सकती, right? Because बाकी दोनों side same है, but ये दो angle जो हैं ये different angles हैं. So in a same triangle, a side opposite to 30-degree and a side opposite to 150-degree cannot be same. Therefore, the diagonals are not equal in case of parallelogram. Okay. Will diagonals be equal in case of rectangle? Obviously, yes. Why it is so? Because if I'm saying that this is A, this is B, in this case, the diagonal will be square root of A square plus B square. But in this case, also the diagonal is root of A square plus B square. So diagonals are equal in the case of rectangle. Will the diagonals be equal in the case of rhombus? No, they will not be equal. Why it is so? The same reason. These two adjacent angles are not same. So if I'm saying that this angle is beta, this diagonal D1 will be opposite to beta, and this diagonal D2 will be opposite to alpha. So because alpha is not same as beta, because alpha और beta को same करोगे तब तो वो square बन जाएगा. So अगर till the moment alpha and beta are not same, so the diagonal opposite to alpha and the diagonal opposite to beta cannot be same. So diagonals are not same in the case of rhombus. Square के केस में क्या होगा? Because all of these angles are equal, ये सारे angles 90 degree के हैं. So can I say that कि square के केस में diagonals will be equal, right? In a case of square, diagonals will be equal. This will be root 2a diagonal, and this will also be root 2a diagonal as per the Pythagoras theorem. So diagonals will be equal in this case, right? So you see that diagonals are equal for rectangle and square, but diagonals are not equal for parallelogram and rhombus. So see that एक property चारों का हो गया, right? Okay, आपको individually cram नहीं करना है ये, right? आपको with logic पता होना चाहिए why the diagonals will be equal for rectangle and square and why not it will be equal for parallelogram and rhombus. Now the next property is that diagonals bisect each other. Now we are going to learn out of these four figures किस figures के अंदर diagonal एक दूसरे को bisect करेंगे. So I start from parallelogram, right? एक के लिए prove हो गया तो बाकियों के लिए आप बहुत easily prove कर सकते हो. Diagonals bisect each other. Okay, if I talk about the parallelogram here, you see that this is diagonal AC, right? And this is diagonal BD. Now, in the case of diagonal AC and BD, you see that, guys. You see that here. If I talk about these two triangles, right? I know that two opposite angles are equal, right? So let's say this P is a point of intersection of the diagonals. right? Diagonals bisect करेंगे या नहीं करेंगे? This is what I need to find out. You see that? If I talk about triangle APB and the triangle CPD, right? You see that? This angle is alpha, then this angle will also be equal to alpha. Why it will be so? Because ये एंगल अल्फा होगा, ये एंगल अल्फा, because these are the alternate angle, ये sides parallel हैं, basic definition parallelogram की. So can I also say that this side angle is beta, then this angle will also be beta, okay? And this angle is also same, vertically opposite angle. ये side भी same होगी. So you see that we have proved that one side is same and all three angles are same. So with angle side angle property, can I say that triangle APB will be congruent to triangle CPD? अगर ये दोनों ट्रायंगल आपस में congruent होंगी तो can I say the length opposite to beta would be same? Beta के opposite side ये and beta के opposite side ये. So can I say that AP will be same as CP, also side opposite to alpha? That means BP will also be same as DP. So these two sides will be equal. That means diagonal are bisecting. Now all I want you to observe is that while I was proving that two triangles are congruent, तो मैंने क्या प्रॉपर्टी यूज किया था? मैंने ये प्रॉपर्टी यूज किया कि अपोजिट साइड पैरेलल हैं, इसलिए एंगल्स इक्वल हैं. तो ये सभी फिगर्स में अपोजिट साइड्स पैरेलल एंड इक्वल होती हैं. यस. एंड on this basic property that opposite sides are parallel and equal, I was able to prove कि ये triangle इस triangle के congruent होगा. So can I prove the congruency between these two triangles for all of these figures? Yes. अगर congruency इन दोनों में prove हो रही है और बाकी सभी figures में भी prove होगा, because congruency जिस proof के ऊपर based है parallelogram की कि opposite sides parallel and equal है, वो तो सभी में ही होगा. So diagonals bisect each other is a one property which is true for all of the four figures. So if you proved it for parallelogram and if you know the proof कि diagonals bisect होने का proof ये है कि ये दोनों triangles congruent हैं और ये congruency का proof ये है कि opposite sides parallel and equal हैं. So because opposite sides are parallel and equal in each of these four figures, so can I also say that diagonals bisect each other is a one property which is applicable for each of the figure. आपको अलग से क्रैम नहीं करना है. Parallelogram के diagonals bisect करते हैं, rectangle के diagonals bisect करते हैं, राइट, रोम्बस के डायगोनल बाइसेक्ट करते हैं, स्क्वायर के डायगोनल्स बाइसेक्ट करते हैं. ये प्रॉपर्टी कॉमन है सभी चारों फिगर्स के अंदर. एंड व्हाई इट इज ट्रू आई हैव जस्ट डिस्कस इट विद यू, राइट? सो डायगोनल्स bisect each other, keep this in mind guys, is a property which is true for all of these four figures, right? Four properties in the previous slide, four here. Now let's move on to the property number 3. Diagonals bisect each other at 90 degree. Previous property was diagonals bisect each other. Now we are going to do the property diagonals bisect each other at 90 degree. Let's talk about the parallelogram. So we'll prove every property for parallelogram and we'll see that how that property behave in rest of the figures, right? वही same property बाकी सभी figure में कैसे behave करेगा, यही अपने को check करना है. Talking about parallelogram now. Okay, these are the diagonals. We have to see. हमें ये देखना है कि diagonals 90 डिग्री पे बाइसेक्ट करते हैं कि नहीं करते हैं. Okay, see that this angle is alpha, this whole angle is alpha, right? And this whole angle is beta. If I want to prove that diagonals bisect each other at 90 degree, that means मेरे को ये prove करना पड़ेगा कि ये दोनों angles equal हैं. Both of these two angles are equal. For that I need to prove कि ये दोनों angles equal हैं. That means I need to prove कि these two triangles are congruent. A, B, C, D and this is P. So what I need to prove is, मुझे ये prove करना पड़ेगा APD and PDC are congruent. First of all, guys, see that this side is same as this side, right? Diagonals bisect कर रहे हैं एक दूसरे को, बिल्कुल कर रहे हैं. ये side दोनों में common है, but this side is not same as this side. अगर ये दोनों side आपस में same नहीं है, because अगर ये same हो गई तो ये parallelogram नहीं होगा. In that case, it will become rhombus. Parallelogram में opposite sides are parallel and equal. अगर इन दोनों adjacents को भी equal करोगे फिर तो parallelogram और rhombus में कोई difference नहीं रहेगा. So parallelogram will become rhombus अगर आप दोनों adjacent side को same करोगे. Now in these two figure ये दोनों sides same है. This side is same as this side. This side is a common side. Now you guys tell me, if these two sides are not same तो क्या इनके opposite angle same हो सकते हैं? नहीं हो सकते, बिकॉज जब आप इन दोनों एंगल, आई नो दैट दिस होल एंगल इज 180 डिग्री, ये पूरा एंगल 180 डिग्री का है। अगर ये दोनों एंगल्स को इक्वल प्रूव करोगे देन यू विल बी प्रूविंग दैट कि ये भी 90 ये भी 90, बट ये दोनों साइड्स अगर सेम नहीं है तो इनके अपोजिट एंगल्स भी सेम नहीं होंगे। एंगल्स सेम नहीं होंगे, दैट मींस बोथ ऑफ दीज टू एंगल्स विल नॉट बी एट 90 डिग्री। So tell me now, when I say this property, the diagonals bisect each other at 90 degree, is it true for parallelogram? It is not true for parallelogram. Similarly, in a case of rectangle, is it possible for me to prove that both of these two triangles are congruent? A, B, C, D. Now tell me guys, if I look at these two triangles, I know that this whole angle are same. Opposite angles तो same होंगे। ये adjacent angle का sum भी 180 होगा। Similarly, you see that diagonals bisect करते हैं, ये हम already देख चुके हैं। ये side दोनों में common है। Now, if these two sides are common, if I want to prove that this angle is same as this angle, I'll have to prove that this side is same as this side. क्या rectangle में ये दोनों sides same होती हैं? If in a rectangle two adjacent sides are same, तो फिर rectangle और square में कोई difference नहीं रहेगा, because the only thing that differentiate between rectangle and square, that differentiate the rectangle and square is that दो adjacent angle का जो summation opposites, ये जो adjacent sides है इनका length same नहीं है। Angle इसमें भी 90 है, इसमें भी समय 90 है। So when these two sides are not equal, these two angles can also not be equal. तो ये अगर अल्फा ले रहा हूँ, ये बीटा, अल्फा is not equal to बीटा। अगर अल्फा बीटा के इक्वल होगा तो ये दोनों साइड्स भी सेम हो जाएंगी, और ये दोनों साइड सेम हो जाएंगे तो रेक्टेंगल स्क्वायर बन जाएगा। So diagonals bisect each other is true for rectangle? No, this is not true for rectangle. Rhombus के केस में, what will happen in the case of rhombus? You see that here, if I draw these two diagonals, A, B, C, D, these are the diagonals that I have, right? These are the diagonals that I have. Now, you see that here, if I talk about these two triangles, right? APB and APD, if I look at these two, you see that here, this side is same as this side. Rhombus definition says that all sides are equal. अगर ये चारों की चारों sides equal है, तो can I say कि ये angle alpha होगा, ये angle भी alpha होगा, ये दोनों sides क्योंकि same दी हुई हैं। Okay, ये side already common है, and diagonals bisect each other. We have already seen it in property number 2. ये हम already property number 2 में देख चुके हैं। तो ये दोनों ट्रायंगल की तीनों साइड सेम होगी और एंगल भी सेम हो गया। तो साइड से आई कैन से दैट ट्रायंगल आर कॉन्ग्रुएंट, दिस ट्रायंगल इज कॉन्ग्रुएंट टू दिस ट्रायंगल। सो अगर ये दोनों ट्रायंगल कॉन्ग्रुएंट है तो ये दोनों एंगल जो होंगे अल्फा और बीटा, ये दोनों सेम हो जाएंगे, एंड अल्फा प्लस बीटा इज 180, सो अल्फा इक्वल टू बीटा विल बी इक्वल टू 90 डिग्री। दैट मींस डायगोनल्स बाइसेक्ट ईच अदर एट 90 डिग्री इन केस ऑफ rhombus? यस। ओके, नाउ डायगोनल्स, ये दोनों एंगल्स को प्रूव कौन कर रहा था? क्योंकि ये दोनों साइड्स इक्वल थी, जिसकी वजह से ये दोनों एंगल्स इक्वल हो गए थे। तो क्या स्क्वायर में भी दोनों एडजेसेंट साइड्स इक्वल होती हैं? यस, ये दोनों साइड्स इक्वल हैं, डायगोनल्स बाइसेक्ट कर रहे हैं, ये साइड सेम है, ये एंगल और ये एंगल सेम होंगे, अल्फा अल्फा। तो कैन आई से कि स्क्वायर में भी डायगोनल्स एक दूसरे को 90 डिग्री पे बाइसेक्ट करेंगे, राइट? सो डायगोनल्स बाइसेक्ट ईच अदर एट 90 डिग्री। If I have to see कि कौन से फिगर में होगा और कौन से फिगर में नहीं होगा, you see that diagonals bisect each other for parallelogram? No. Rectangle? No. Proof we have just seen. Rhombus? Yes. Square? Yes. Right? That's the property number 3. So जो पहला property था, the first property that we discussed, diagonals are equal. ये दो में true था, rectangle and square के अंदर, parallelogram और rhombus में नहीं true था। Next property हमने discuss किया कि diagonals bisect each other, ये सब में true है। थर्ड प्रॉपर्टी हमने सभी के लिए डिस्कस किया, द डायगोनल्स बाइसेक्ट ईच अदर एट 90 डिग्री, इट इज ट्रू ओनली फॉर दीज टू फिगर, नॉट फॉर दीज टू फिगर्स, राइट? तीन प्रॉपर्टीज चारों फिगर्स के लिए हमारा हो गया। गोइंग टू द नेक्स्ट प्रॉपर्टी, 4 डायगोनल्स आर एंगल बाइसेक्टर। क्या डायगोनल्स एंगल बाइसेक्टर होंगे? लेट्स सी दैट, A, B, C, D. Let's draw the diagonals here. Is this angle same as this angle? This is what I need to see. I need to prove that alpha is same as beta, right? If I can prove that alpha is same as beta, that means I'll be able to prove that diagonals are angle bisector in case of parallelogram. Let's see that. Is it true or not? You see that this side, if you look at these two triangles, this side is same as this side is same as this side. ये side तो हमारा common हो गया. So ये दोनों triangle आपस में congruent है, right? Both of these two are congruent, right? So, and this angle is beta, right? ये दोनों ट्रायंगल आपस में कॉन्ग्रुएंट है, सो बीटा के अपोजिट साइड ये है और बीटा के अपोजिट साइड ये है. सो ये एंगल और ये एंगल इक्वल है, राइट? Now, is it possible to, when I prove that alpha is same as beta, तो alpha के opposite side और beta के opposite side same हो जाएंगे. Now, parallelogram में I know that कि ये side और ये adjacent side same नहीं है. अगर आप इनको same करोगे तो ये parallelogram नहीं होगा, फिर तो ये rhombus बन जाएगा. So, alpha के opposite side, ये length के parallelogram के length के opposite वाला angle है alpha और width के opposite वाला angle है beta. Can they be same? बिकॉज अगर ये दोनों सेम होंगे तो ये दोनों साइड्स भी सेम होंगी, फिर पैरेललोग्राम नहीं होगा, वो रोम्बस हो जाएगा. सो डायगोनल्स will diagonals be acting as angle bisector in parallelogram? Not possible, because the moment diagonals will be same as angle bisector, diagonals will also be same as angle bisector. In that case ये एंगल अल्फा होगा, तो ये वाली साइड और ये वाली साइड सेम होंगी, तो पैरेललोग्राम फिर रोम्बस बन जाएगा. इट विल नॉट बी पैरेललोग्राम. So diagonals are not angle bisector in parallelogram. What will happen in the rectangle? Same is true for rectangle also. You see that? A, B, C, D. If you look at this figure, okay. This side is same as this side. This side is same as this side. ये side common. Triangle आपस में congruent होगी. तो you see that ये दोनों angle alpha और beta. You see that? Alpha की opposite side length है. Beta की opposite side width है. They cannot be same, right? Beta will be same as this angle. ये एंगल और ये एंगल सेम है, तो इनकी अपोजिट साइड सेम होगी. ये दोनों सेम अगर हो जाते हैं तो ये साइड और ये साइड को सेम होना पड़ेगा. देन रेक्टेंगल विल बी कॉल्ड एज अ स्क्वायर, नॉट रेक्टेंगल. सो डायगोनल्स आर नॉट एंगल बाइसेक्टर इन केस ऑफ रेक्टेंगल आल्सो. व्हाट अबाउट रोम्बस? क्या रोम्बस के अंदर डायगोनल्स विल बी एक्टिंग एज एन एंगल बाइसेक्टर? लेट्स चेक इट. A, B, C and D. Look at these two triangles. ये साइड के सेम है, ये साइड सेम है. दिस इज कॉमन. ट्रायंगल आर कॉन्ग्रुएंट. ट्रायंगल कॉन्ग्रुएंट होंगी तो बिकॉज दिस साइड इज सेम एज दिस साइड, तो इनके अपोजिट के एंगल्स भी सेम होंगे. तो ये भी अल्फा, तो ये भी अल्फा. डायगोनल्स आर एंगल बाइसेक्टर इन रोम्बस. यस, स्क्वायर में तो टेंशन ही नहीं है, बिकॉज द प्रॉपर्टी व्हिच वाज प्रूविंग द डायगोनल एज एन एंगल बाइसेक्टर वाज दैट बोथ ऑफ द टू adjacent sides are equal. So क्या ये प्रॉपर्टी स्क्वायर में भी होती है? Yes, this property is also valid in square. ये साइड सेम है, राइट? ऑल थ्री साइड्स आर सेम, तो ये दोनों एंगल्स इक्वल होंगे. अल्फा विल बी इक्वल टू अल्फा. सो डायगोनल्स आर एंगल बाइसेक्टर ओनली इन रोम्बस एंड स्क्वायर, नॉट इन पैरेललोग्राम एंड रेक्टेंगल, राइट? सो if I remove this and write it again, diagonals are angle bisector, not for parallelogram, not for rectangle, yes for rhombus, yes for square, right? 4 properties for each of the 4 quadrilaterals, right? Moving on to the property number 5. Okay, 1/3 part done. Opposite angles are equal. Okay, this is the basic property. I guess ये property हम already prove कर चुके हैं. Opposite angles are equal. We know that alpha plus beta is 180 and beta plus this angle is also 180. So these two opposite angles will be equal. Yes. Okay. You see that these two opposite angles are equal, right? Okay. Rectangle में तो सारे angles ही 90 डिग्री के होते हैं. Opposite angles तो equal होंगे. Rhombus में adjacent angles का sum 180 होता है और इन दोनों का भी sum 180 होगा, तो इसको अल्फा होना पड़ेगा. So opposite angles equal हो गए. ये सब में 90 डिग्री होते हैं. Opposite angles are equal. Actually में ये बहुत बेसिक प्रॉपर्टी है, हमने डेफिनेशन के साथ ही कर लिया. It's applicable for all 4 figure. 5 done, right? Property number 6. Figure formed by joining the midpoints of the side. Now, this is something very interesting. Very, very interesting, right? Advanced level property. Few students know about this. That when I join the midpoint of the figures, what is the figure form, right? So if I say this is a figure A, B, C, D. Now I'm joining the midpoint of all of these 4 sides, right? If I'm joining the midpoint of all of these sides, guys, right? Okay. So I'll be getting a new figure. This new figure is PQRS. All I have to prove is the PQRS जो figure बनेगा, उसका shape क्या होगा? अभी ये बहुत अच्छे लेवल की प्रॉपर्टी और बहुत कम बच्चों को पता होती है और इस पे आपको डायरेक्ट क्वेश्चन भी मिल सकता है, राइट? सी दैट सीरियस टाइप के एग्जाम में तो इस पे डायरेक्ट क्वेश्चंस आते हैं प्रॉपर्टीज पे, राइट? कैट में भी डेफिनेटली आ सकते हैं, एसएससी सीजीएल. इट्स वेरी वेरी इंपॉर्टेंट फॉर प्रॉपर्टी फॉर ऑल ऑफ द फिगर्स और बहुत अच्छे क्वेश्चन आप इस प्रॉपर्टी के बेसिस पे सॉल्व कर सकते हो, राइट? सो व्हाट यू डू इज गाइस, सी दैट I would like all of you to know the midpoint theorem of a triangle. ये property में midpoint theorem of triangle बहुत ज्यादा यूज होगा, तो मैं आपको पहले से वो midpoint theorem बता देता हूँ. Triangle ABC के अंदर, if I join the midpoint of AB and AC, let's say D is a midpoint of AB, E is a midpoint of AC, then the line joining D to E will be parallel to BC. Midpoints को जो line join करेगी, that line will be parallel to BC. And the length DE will be half of BC. Now this is a midpoint theorem. कहां से आया? बहुत easy है, similarity से आया. ये side ये एंगल इसके एंगल के इक्वल है. और sorry, if I'm saying that D is a midpoint, तो ये साइड और ये साइड सेम होगी, ये साइड और ये साइड सेम होगी. तो you look at the triangle ADE and look at the triangle ABC. AD और AB का रेशियो, AE और AC का रेशियो सेम हो गया. और ये एंगल तो सेम है. तो this triangle ADE is same as similar to the triangle ABC. अगर ट्रायंगल सिमिलर होंगे तो ये दोनों एंगल्स इक्वल होंगे, दोनों एंगल्स इक्वल होंगे तो DE BC के पैरेलल होगा. और DE का लेंथ और BC का लेंथ का रेशियो जो होगा that would be same as AD and AB, which is 1/2. is a midpoint theorem, right? ट्रायंगल का midpoint theorem है. जिस बच्चे को नहीं आता मैंने बेसिक्स आपको बता दिया, इसलिए बताया बिकॉज ये प्रॉपर्टी आपके यहाँ पे यूज होने वाली है, राइट? पैरेललोग्राम के अंदर you see that when I'm joining the midpoint, you see that if I say that diagonal का length, let's say diagonal का length is, ये जो diagonal का length है ये D है. Can you see that कि P is a midpoint, S is a midpoint, right? Why? Because it's given. Because there's a property we are discussing कि midpoint को join करने से अंदर जो figure बनेगा वो figure कौन सा बनेगा. Now carefully observe करो that triangle ABD के अंदर P is a midpoint, S is a midpoint. Now line joining the midpoint is parallel to this line. Line joining the midpoint, right, P to S is parallel to this line and this will also be half of the length of BD. तो ये जो length होगा ये D/2 के equal होगा. If I say that this, let's say D1, this is D1, this is diagonal D1, तो ये D1/2 के equal होगा. Okay, similarly triangle CDB के अंदर भी QR का जो length होगा वो भी half of diagonal होगा, D1/2 होगा, right? Now you guys tell me, diagonals are equal. ये जो पहला property हमने किया था, we know that diagonals are equal for rectangle and square. Diagonals of rhombus and diagonal of rhombus and parallelograms are not equal. So when I'm saying that कि ये diagonal D1 का है, तो can I say जो दूसरा इसका diagonal होगा, this diagonal, right? This will be a different length D2. अगर ये लेंथ D2 का होगा तो PQ का लेंथ विल बी D2/2 एंड दिस विल आल्सो बी D2/2. ठीक है, तो ये जो अंदर फिगर बन रहा है PQRS, क्या इसकी चारों साइड सेम है? नहीं है, चारों साइड सेम नहीं है, राइट? अपोजिट साइड सेम है. अपोजिट साइड सेम है तो इसका मतलब जो PQRS होगा, फिगर PQRS में अपोजिट साइड सेम है तो वो डेफिनेटली रोम्बस तो नहीं हो सकता है. It will definitely not be a rhombus and it will definitely not be a square. क्यों? Because चारों साइड सेम नहीं है. क्यों चारों साइड सेम नहीं है? Because diagonals पैरेललोग्राम के सेम नहीं है. ये diagonals के आधी लेंथ के इक्वल है, ये इस diagonal का आधा है, ये भी इसी diagonal का आधा है. This length is half of this diagonal, this length is half of this diagonal, right? तो because इनकी diagonals का लेंथ सेम नहीं होने की वजह से चारों साइड सेम नहीं आई, तो rhombus and square are out of the option, right? Okay, opposite sides parallel हैं क्या? Yes. Using the midpoint theorem, I can say that PS is parallel to BD. PS is parallel to BD. And QR is parallel to this side. ये जो length है ये इसके parallel है. Now this is parallel to this, this is parallel to this. Can I say कि ये आपस में opposite वाली sides भी parallel होंगी. These two will also be parallel. Okay. ये दोनों sides अगर opposite वाली parallel होंगी तो सिमिलरली ये इसके पैरेलल और ये इसके पैरेलल, तो ये दोनों साइड्स भी आपस में पैरेलल होंगी. तो अपोजिट साइड्स पैरेलल भी होगी, इक्वल भी होगी. दैट मींस ये फिगर या तो बनेगा रेक्टेंगल या फिर बनेगा पैरेललोग्राम. ओके, अभी ये फिगर या तो पैरेललोग्राम है या रेक्टेंगल है. अब पैरेललोग्राम और रेक्टेंगल में डिफरेंस होता है. एंगल्स आर सपोज्ड टू बी 90 डिग्री. टू एडजेसेंट एंगल्स ये जो है ये दो एडजेसेंट साइड के बीच में एंगल 90 का होता है, बट पैरेललोग्राम में ये एंगल 90 का नहीं होता है. अब मुझे ये देखना है कि ये जो एंगल यहाँ पे बन रहा है ये 90 डिग्री का है कि नहीं है. अगर ये 90 डिग्री का हुआ, दिस फिगर विल बी कॉल्ड एज अ रेक्टेंगल. इफ इट इज नॉट 90 डिग्री, देन इट विल बी कॉल्ड एज अ पैरेललोग्राम. ओके, सो गाइस, इफ आई से दैट कि ये साइड पैरेलल है, ये साइड ये पैरेलल है, तो ये जो छोटा सा फिगर आपको दिख रहा है, दिस वुड डेफिनेटली बी अ पैरेललोग्राम बिकॉज एवरी रेक्टेंगल इज अ पैरेललोग्राम बट एवरी पैरेललोग्राम इज नॉट अ रेक्टेंगल. तो चाहे ये रेक्टेंगल हो या पैरेललोग्राम, और पैरेललोग्राम की तो सारी प्रॉपर्टीज इसमें लगेंगी, राइट? नाउ यू सी दैट इफ आई वांट टू प्रूव कि ये एंगल 90 डिग्री का है तो मुझे ये एंगल 90 डिग्री का देखना पड़ेगा, क्योंकि अगर ये 90 का हो तो अपोजिट एंगल्स विल बी सेम। ये साइड के पैरेलल है, ये साइड के पैरेलल है, इसमें अपोजिट एंगल्स इक्वल होते हैं। तो अगर ये 90 का हो तो ये भी 90 का है। नाउ टेल मी, अभी जो हमने प्रॉपर्टी नंबर 3 किया, डायगोनल्स बाइसेक्ट ईच अदर एट 90 डिग्री, ये किस में ट्रू था? Diagonals bisect each other at 90 degree. This is not true for parallelogram and rectangle. It is true for rhombus and square. तो parallelogram में diagonals 90 पे bisect नहीं करते। अगर diagonal 90 पे bisect नहीं करते, that means ये जो angle बन रहा है, this angle is not 90 degree. Can I say that this angle is not 90 degree? अगर ये 90 नहीं है और ये parallelogram तो definitely है, तो opposite वाला angle भी 90 नहीं होगा। तो ये 90 नहीं है। That means जो PQRS जो फिगर होगा, ये रेक्टेंगल नहीं हो सकता, क्योंकि एडजेसेंट एंगल्स 90 डिग्री के नहीं है। तो फिर ये क्या होगा? इट वुड बी अ पैरेललोग्राम, राइट? सो इसको पैरेललोग्राम बोलेंगे। तो पैरेललोग्राम के मिड पॉइंट को ज्वाइन करने से जो फिगर होगा, दैट विल बी कॉल्ड एज अ पैरेललोग्राम। नाउ द सेम प्रॉपर्टी, लेट्स सी दैट हाउ दिस सेम प्रॉपर्टी विल बिहेव इन केस ऑफ रेक्टेंगल। नाउ अभी यही प्रॉपर्टी रेक्टेंगल में कैसे बिहेव करेगी, दिस इज समथिंग वी नीड टू चेक। नाउ सी दैट अब you can easily tell now कि if I join the midpoints of rectangle here, rectangle के अगर मैं midpoints को join करता हूं तो you see that कि ये opposite side diagonals rectangle के equal होते हैं क्या? Yes, diagonals rectangle के equal होंगे। तो ये अगर d होगा तो ये d by 2 होगा, ये भी d by 2 हो जाएगा, right? क्यों हो जाएगा? Because of midpoint theorem। अभी हमने just इस फिगर में डिस्कस किया midpoint theorem को। सिमिलरली ये डायगोनल और ये डायगोनल्स इक्वल है, तो सेकंड वाला डायगोनल मैं ड्रॉ नहीं कर रहा हूं, बिकॉज दैट विल, चलो ड्रॉ कर देते हैं, राइट? ये सेकंड डायगोनल है, तो कहना है कि ये वाली लेंथ भी d/2 और ये भी d/2 है। तो रेक्टेंगल के केस में आप देख सकते हो बच्चों कि चारों साइड सेम है, चारों साइड सेम है। तो PQRS रेक्टेंगल के केस में रेक्टेंगल नहीं होगा, पैरेललोग्राम भी नहीं होगा, या तो रोम्बस होगा या स्क्वायर होगा, बिकॉज चारों साइड्स को आपने इक्वल प्रूव कर दिया, राइट? तो इन दोनों में से कोई एक फिगर बनेगा रेक्टेंगल के केस में। ओके, नाउ लेट्स चेक इट। नाउ ओके, all four sides are equal. Now tell me, if this is 90 degree, then it will be a square. If this is not 90 degree, then it would be a rhombus. If now this is small figure is a parallelogram, ये साइड इसके पैरेलल है, ये साइड इसके पैरेलल है। तो अगर इसको 90 प्रूव करना है तो इसको 90 प्रूव करना पड़ेगा। नाउ यू गो बैक टू द प्रॉपर्टी नंबर 3, डायगोनल्स आर एट 90 डिग्री, डायगोनल्स बाइसेक्ट ईच अदर एट 90 डिग्री ओनली फॉर रोम्बस एंड स्क्वायर। क्या रेक्टेंगल के डायगोनल 90 डिग्री में बाइसेक्ट करते हैं? नहीं करते। नहीं करते तो ये एंगल अल्फा जो बनेगा ये 90 नहीं बनेगा, ये नहीं बनेगा तो ये भी 90 नहीं बनेगा। अगर ये एंगल 90 नहीं है तो PQRS स्क्वायर हो सकता है क्या? स्क्वायर नहीं हो सकता, तो फिर ये रोम्बस होगा। गॉट इट? सो रेक्टेंगल के केस में मिड पॉइंट को ज्वाइन करने से रोम्बस बनता है। लेट्स टॉक अबाउट रोम्बस नाउ। रोम्बस में इफ आई से these are the midpoints I'm joining it, right? क्या रोम्बस के डायगोनल्स इक्वल होते हैं? नहीं होते, we have just seen it, right? वो हमने प्रॉपर्टी नंबर 1 में यही किया, डायगोनल्स किसके इक्वल होते हैं और किसके इक्वल नहीं होते। So if I draw this diagonal now, right? This is A, this is B, this is C, and this is D, right? Diagonal AC is D, right? AC is D, and your BD is D1, let's say, and BD is D2. The diagonals are not equal. तो ये जो PQ का लेंथ होगा, right? The length of PQ will be half of these two, right? This will be D2/2, this will be D2/2, this would be D1/2, and this will be D1/2. Okay. So opposite sides equal हो गई। तो अगर opposite sides equal है, क्या adjacent side equals है? Adjacent side equal नहीं है, because rhombus के diagonals are not equal. अगर adjacent side equal नहीं है, तो can I say कि square and rhombus तो बन नहीं सकता है इस केस में? Square and rhombus will definitely not be this, will not be the case, right? अगर square नहीं है, right? अगर adjacent side same नहीं है, all I have to see is कि ये angle कौन सा है। Diagonals जो है rhombus के 90 डिग्री पे bisect करते हैं, yes. Property number 3 में we have just covered diagonals of rhombus are at 90 degree, bisect each other at 90 degree. If they bisect each other at 90 degree, तो ये एंगल 90 है और ये पूरा पैरेलल, अपोजिट साइड्स पैरेलल है, तो ये एंगल भी 90 डिग्री का होगा, राइट? तो अगर ये 90 का हुआ, दैट मींस ये पैरेललोग्राम नहीं होगा, ये रेक्टेंगल होगा, राइट? सो यू सी दैट रेक्टेंगल के मिड पॉइंट्स को ज्वाइन करने से रोम्बस बना, और रोम्बस के मिड पॉइंट्स को ज्वाइन करने से रेक्टेंगल बना, राइट? पैरेललोग्राम के मिड पॉइंट्स को ज्वाइन करने से पैरेललोग्राम बना. लेट्स टॉक अबाउट द केस ऑफ स्केयर नाउ. स्केयर के मिड पॉइंट्स को ज्वाइन अगर आप करोगे, इफ आई ज्वाइन द मिड पॉइंट्स ऑफ द स्केयर्स, राइट, P, Q, R, S. If I join the midpoints of the scale, अगर आपने ये साइड्स को ज्वाइन किया, then you see that ये सारी लेंथ डेफिनेटली सेम होंगी बिकॉज स्केयर के डायगोनल सेम होते हैं. तो कैन आई अज्यूम कि ये सारे लेंथ्स डायगोनल्स के हाफ होंगे, राइट? ये D होगा. I don't need to do that, right? This would definitely be D, 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 and D, right? Now all I have to see is कि ये एंगल क्या है. See that स्केयर के डायगोनल जो होते हैं वो 90 डिग्री पे बाइसेक्ट करते हैं. ये एंगल 90 है तो ये भी 90 होगा. तो चारों साइड्स भी सेम होगी और ईच ऑफ द एंगल इज ऑल्सो इक्वल टू 90 डिग्री. तो कैन आई से कि स्केयर के मिड पॉइंट्स को ज्वाइन करने से स्केयर बनता है, राइट? इज इट क्लियर? नाउ लेट मी दिस इज अ वेरी इंपॉर्टेंट प्रॉपर्टी. लेट मी just give you one again, a brief of all of these figures, right? So what we are trying to do in this property is we are trying to see that. Just take a screenshot if you want to take, because I'm going to erase this whole data and will give you a brief on it, right? Okay. So what we have discussed in property number 6 is that the figure found by joining the midpoints of parallelogram would be a parallelogram itself, right? इसके मिड पॉइंट्स को ज्वाइन करने से जो PQRS जो फिगर बनेगा, PQRS, right? PQRS in this case will be a parallelogram itself, right? रेक्टेंगल के मिड पॉइंट्स को ज्वाइन करने से जो फिगर बनेगा, that would be a रेक्टेंगल के मिड पॉइंट्स को ज्वाइन करने से इस केस में जो PQRS फिगर बनेगा, that would be rhombus, right? और rhombus के मिड पॉइंट्स को ज्वाइन करने से जो बनेगा, that would be rectangle. और स्केयर के मिड पॉइंट्स को ज्वाइन करने से जो फिगर बनेगा, दैट वुड बी स्केयर. नाउ यू कैन इजीली कीप दिस इन माइंड. डोंट डू द रट्टाफिकेशन. इनफैक्ट अंडरस्टैंड द बेसिक रूल्स. पैरेललोग्राम की मिड पॉइंट करने से पैरेललोग्राम, रेक्टेंगल में रोम्बस, रोम्बस में रेक्टेंगल, स्केयर में स्केयर, राइट? सो रेक्टेंगल और रोम्बस आपस में एक्सचेंज हो रहे हैं. पैरेललोग्राम में पैरेललोग्राम रह रहा है, स्केयर में स्केयर रह रहा है. So these are the 6 properties that we have covered. 6 more properties will be covered that I'll discuss in part 2 of this video. Right? So in one shot, right, we'll be able to do all these properties. Part 2 mein, I'll be discussing rest of the 6 properties of these 4 figures in exactly in the same manners with proof. So 12 properties hone ke baad, your whole chapter will be done. So wait for part 2 of this video, right? Will be uploaded soon on the channel. Subscribe to the channel to cover your complete Quant and DILR syllabus for MBA entrance exams like CAT, IFT, ZAT, SNAP, and MAT. Also for students appearing for government jobs exams like SSC, CGL, Bank PO, and CDS. This channel will help you in covering your complete syllabus, complete theory of Quant, DI, and logical reasoning. Thank you so much for watching the video. See you in the next part. Hello everyone, welcome back. Welcome to Easy Ganit. This is part 2 of Quadrilateral, where we are learning complete quadrilateral with 48 properties, 12 properties for each of these figures in one single shot. Completely a new way, a unique way to learn these properties. And believe me, once you do these videos, right, you will be done with 48 properties of quadrilateral, right? And with a much better understanding, because we are doing every property with proof. राइट. सो फर्स्ट पार्ट के अंदर बच्चों हमने 6 प्रॉपर्टी डिस्कस की थी. प्रॉपर्टी 1, 2, 3, 4, 5, 6. प्रॉपर्टी नंबर 1 वाज द डायगोनल्स आर इक्वल. सो वी लर्नड विद प्रूफ. ऑलरेडी वी हैव लर्नड इन पार्ट 1 डायगोनल्स आर इक्वल. Diagonals are equal for rectangle. Diagonals are equal for rectangle and square, right? Diagonals are equal for rectangle and squares, right? So let me just give you a quick revision कि first part में हमने क्या डिस्कस किया था. Diagonals are equal for rectangle and square. They are not equal for parallelogram and rhombus. We have done the proof of it. Please watch part 1. Okay. Diagonals bisect each other. Diagonals bisect each other for all of these 4 figures, right? This is a property that is true for all of these figures. Again, the proof is in the part 1. Please have a look at it. Diagonals bisect each other at 90 degree only for rhombus and square, not for rectangle and parallelogram. Proof is in the part 1. Diagonals are angle bisector. Diagonals are angle bisector for rhombus and square, and the reason have been discussed in part 1. Property number 5 that we discussed was opposite angles are equal. Opposite angles are equal in all 4 of these figures. This was a basic property, right? Figure formed by joining the midpoints of the sides. So when you join the midpoints of the sides of this figure, the new figure that you'll be getting would be called as, in case of parallelogram, on joining the midpoints, right? So see that on joining the midpoints of the figure PQRS, in case of parallelogram, this PQRS will be called as a parallelogram, right? Right. Again, the proof of it is in part 1. And in case of rectangle, right, when you join the midpoints, in case of rectangle, you will be getting rhombus, right? And in case of rhombus, the midpoint, the line, if you join all the midpoints, you will be getting rectangle. And in case of square, when you will be joining the midpoints of the square, you will be getting a square again. So this was the last property that we discussed in the part 1. I'm going to do 6 more properties with proof exactly in the same way we have covered these 6 properties in part 1. So now let's start with property number 7, everybody. I hope you have got the complete revision of it. So if you want to learn the proof of it, watch part 1. Property number 7, area of quadrilateral in terms of diagonal. If I have to find out the area of the quadrilateral in terms of diagonal, what is that? Area of quadrilateral. In fact, this property that I'm just going to tell you is also applicable for all types of quadrilateral, whether it's a parallelogram or rectangle or rhombus or square. ये जो property है, area of quadrilateral in terms of diagonal, it's applicable for all possible quadrilateral. Any polygon made of 4 sides, this area of quadrilateral in terms of diagonal will be applicable. You see that if I take any possible quadrilateral, right? I'm not saying that it's a parallelogram or rectangle or rhombus or square, right? Any quadrilateral made of 4 sides, A, B, C, D. Now, if I join the diagonals, let's say that these are the 2 diagonals, right? AC and BD. Let's say this side is A, this side is, let's say, B, this side is C, and this side is, let's say, D. If I have to find out the area of this triangle, area of triangle APB, area of this triangle APB would be half into A into B into sine theta. Let's say that this is theta. Now this, you see that will be the angle which is 180 minus theta. Now this area, right, now this is the area of triangle. You should know that in terms of angle, if 2 adjacent length is known and the angle between these 2 sides is known, area is half into A into B sine theta. Area of this triangle would be half into B into C into sine 180 minus theta. And you should know that sine 180 minus theta is sine theta, right? So is triangle ki baat kare. So this triangle will have area as half into CD sine theta. And this area would be half into AD sine theta. Now if I add all these 4 areas, agar ye charo areas ko main add karta hu, if I add all these 4 areas, it will be equal to half into, you see that half sine theta will be common and you will be left with AB plus BC plus CD plus AD plus CD plus AD. Now, can I take A, B common from these 2? This will be A plus C. And if I take D common from these 2, I'll be left with again A plus C. Now, taking this as common, half into sine theta. Can I take common A plus C? Now, you will be left with B plus D inside the bracket. Now, you see that? Area would be half into sine theta into A plus C. What is A plus C? A plus C is my first diagonal AC, D1, right? And what is B plus D? B plus D is my second diagonal, that is D2. So what I want all of you to know is area of all of these 4 figures in terms of diagonal, which is half into D1 into diagonal 1 into D2 into sine of theta. That means angle between those 2 diagonals. This is applicable for all figures. इसका भी area half into D1 into D2 sin theta, इसका भी. In fact, it is applicable for all possible quadrilateral, right? So ये जो formula है, एरिया को निकालने का half into d1 into d2 sin theta is applicable for all of those figures, right? Also, I would like you to know one more property in terms of area of triangle here. We'll keep this as a property number 7 only because the proof of it is coming from the same basics that we have just written down over here. You see that if I say that this area is A1, let's say this is A1 area, this is A2 area, this is A3 area, and this is A4, right? And let me create a space here. So we already have done the proof of it. Now see that if I multiply A1 area with A2 area, you see that if I multiply A1 with A2, now A1 multiplied by A2 will be equal to half into ABCD sine square theta, half into ABCD sine square theta. Similarly, A3 multiplied by A4 will be equal to half into AD sine theta, BC sine theta. That is again ABCD sine square theta. Now you observe it carefully that the product of area of these two opposite triangle A1 multiplied by A2 is same as product of area of these two opposite triangle. A1 into A2 is equal to A3 into A4. The product of these two areas is same as the product of these two areas. So examiner might give you a question where 3 of these areas are given and you're supposed to find out the 4th area. Then you can straight away apply this property. And you see that कि इस area को ये property को prove करने के लिए हमने कोई specific parallelogram की या rectangle की कोई property use नहीं की है. We have simply used the area of triangle in terms of theta. So that means this property of A1, A2, A3, A4 will also be applicable for parallelogram, rectangle, rhombus and sphere. So keep this in mind. In property number 7, area of triangle in terms of diagonal half into D1 into D2 sin theta is applicable for all 4 figures, as well as A1 into A2 is equal to A3 into A4 is also applicable for all of these 4 figures, right? So 7th में हमने 2 property एक हिसाब से cover कर लिया, and both of these 2 properties are universally true for all quadrilaterals, right? किसी भी तरह का quadrilateral होगा, ये property आपका definitely चलेगा. In fact, this will also be applicable. These properties will also be applicable for trapezium as well as for kite, right? So बाकी के लिए भी ये बाकी quadrilaterals के लिए भी ये चलेगा. Property number 8. Area property when any random point inside the figure joined with the vertices. So guys, you see that in all of these figures, if I pick any random point inside the figure, let's say I'm taking a point P here, and when I'm joining this point P with all 4 vertices, now this is not the point of intersection of diagonals, keep this in mind. I'm taking any random point P here. This is my figure A, B, C, D here. Now, what is area property when a random point P is taken inside the figure and joined with all 4 vertices? P is not the point of intersection of diagonals. Keep this in mind, okay? Now, you see that if I have to find out the area of triangle APB plus area of triangle DPC. Look at these 2 triangles, guys. See that both of them opposite sides are parallel and equal. So if I'm saying that this length is B, this length will also be B. And now if I drop a perpendicular H1 from the point P, and if I drop a perpendicular H2 from the point P, then you see that area, summation of area of both of these 2 figures, you see, would be half into B into H1 plus H2, right? Now what is H1 plus H2? H1 plus H2 is the distance between the 2 parallel lines. Now let's say distance between these 2 parallel lines is equal to H, right? So can I also say that this is half into B into H? Now what is B into H? B into H is the area of whole parallelogram ABCD. Area of whole parallelogram ABCD divided by 2. Now if the summation of area of these 2 triangles is half of the whole parallelogram ABCD, can I also say कि जो बाकी की दोनों triangles बची हैं उनका area भी half होगा. So what you are supposed to do, what you are supposed to keep in mind is that any random point while taken inside, which is taken inside the figure and joined with all the vertices, Then 4 triangles that you'll be getting, इसका एरिया A1 है, इसका एरिया A2 है, let's say इसका एरिया A3 है, इसका एरिया A4 है. Then you can see that we have just proved that A1 plus A2, पहला triangle A1 plus A2, summation of the area of two opposite triangle. A1 plus A2 का जो value होगा, that will be same as A3 plus A4, which would be same as half of complete parallelogram, area of complete parallelogram ABCD. Now, ये property को prove करने के लिए the main factor that we have used while proving it is कि ये दोनों sides का length equal है और दोनों parallel है. दोनों length equal है तो हमने B common लिया और दोनों parallel हैं, that's why we are putting H1 plus H2 as equal to H. Now, opposite sides are parallel and equal. Rectangle में भी होता है, rhombus में भी होता है, sphere में भी होता है. And दोनों opposite sides parallel है, right? तो H1 plus H2 सब में H के equal होगा. तो can I say कि ये जो property लिखा हुआ है A1 plus A2 is equal to A3 plus A4 is equal to half of whole parallelogram ABCD, that will be true for all 4 figures, right? Because इसका जो proof है वो basic, इसको prove करने के लिए जो requirements हैं वो सभी के अंदर fulfill होंगी, right? So अगर मैं rectangle में भी कोई internal point P लूंगा and if I join it with all the 4 figures, in this case also A1 plus A2 will be equal to A3 plus A4. A1 plus A2 is equal to A3 plus A4 and this will be equal to half of all rectangle ABCD. Same is true for rhombus. Rhombus में भी ये true होगा बच्चों, right? So random point लेने से चारों figures को अगर join करोगे, A1 plus A2 will be same as A3 plus A4 and the same property will be true for sphere also. ये आपका property number 8 सभी 4 figures के लिए हो गया. Now this is a figure जिसमें आपको ध्यान रखना है कि opposite sides parallel होनी चाहिए, right? And equal भी होनी चाहिए. So will it work in trapezium? ये trapezium में काम नहीं करेगा. इन चारों figures में ही काम करेगा, right? Now let's go to property number 9. Area property when any random point inside the figure join the midpoints of the side. Now ये जो question ये बहुत अच्छा property है, property number 9. Now here any random point inside the figure is not joined with the vertices, in fact it is joined with the midpoints. तो मैंने एक random points लिया, right? Let's say कि ये मेरा figure है A, B, C, D और ये random point को मैंने ये सभी midpoints के साथ join कर दिया, right? This is P, this is Q, this is R, this is S. I'll get 4 quadrilateral A1, A2. What we are supposed to find out now is the relationship between these areas. ये relation इनके बीच में क्या relation होगा? Now property number 9 का proof is actually a combination of property number 6 and property number 8 जो अभी हमने किया. 6 property में आपको ध्यान होगा. Property number 6 में हमने ये किया था कि parallelogram के midpoints को अगर हम join करेंगे तो अंदर जो figure मिलेगा वो खुद एक parallelogram होगा, right? So if I join these midpoints, I'll get PQRS will be a parallelogram. So property number 8 में we have just covered कि any random point when joined with the vertices of PQRS itself is a parallelogram. PQRS खुद एक parallelogram है जिसके अंदर एक point P है जिसको आपने चारों vertices से join किया. तो can I say कि ये जो areas होंगे A, B, C और D, तो can I say कि A plus B का जो value होगा, A, B, C, D are the areas of the respective triangles. A plus B का जो वैल्यू होगा that will be same as C plus D. Okay, ये तो property number 8 जो अभी हमने प्रूव किया इससे जस्ट पहले. And then you see that कि parallelogram की sides length, opposite side lengths are parallel and equal. तो आप देखो ये साइड इसके इक्वल है और ये साइड इसके इक्वल है. क्यों? क्योंकि ये R, S और P मिड पॉइंट होंगे. Now if they are the midpoint, can I say that ये लेंथ और ये लेंथ सेम है, ये लेंथ और ये लेंथ भी सेम है. सो इन दोनों का जो एरिया आएगा वो भी इक्वल आएगा. सो ये पूरे पार्ट में से ए का एरिया अगर मैं माइनस करूं तो बाकी जो एरिया बचेगा, दिस एरिया जहां पे मैं टिक मार्क लगा रहा हूं, ये सारे एरियाज आपस में इक्वल है. आई एम नॉट नेमिंग देम, थोड़ा इक्वेशन वाइज और भी कॉम्प्लेक्स हो जाएगा. सो अगर ये चारों एरियाज इक्वल हैं तो ए के अंदर आपने कुछ ऐड किया, डी के अंदर भी कुछ ऐड किया, बी के अंदर भी कुछ ऐड किया और सी के अंदर भी कुछ ऐड किया और एबीसीडी में जो कुछ आप ऐड कर रहे हो वो चारों के लिए सेम है. सो ए में लेट्स से कि ये एरिया K है तो ये एरिया भी K होगा, ये एरिया भी K होगा, ये एरिया भी K होगा. सो नाउ सी दैट इफ आई एम एडिंग K ऑन बोथ साइड, A plus K, B plus K will be equal to C plus K plus D plus K. So चारों तरफ आपने K ऐड किया, सेम वैल्यू. नाउ A plus K is what? It is A1. D plus K is what? It is A2. C plus K is what? It is A3. D plus K is what? A4. You see that A1 plus A2 is equal to A3 plus A4 will be applicable in parallelogram, right? Okay. Because ये जो प्रॉपर्टी था हमने प्रॉपर्टी नंबर 8 में देखा कि अगर वर्टिसेस से आप ज्वाइन कर रहे हो तो A1 plus A2 सेम एज A3 plus A4, ये चारों के लिए ट्रू था. अगर ये चारों के लिए ट्रू है तो अगर मैं रेक्टेंगल के अंदर भी कोई इंटरनल पॉइंट लेता हूं और उसको बाकी सभी वर्टिसेस से ज्वाइन करूंगा, राइट, तो इसमें भी चलेगा वो, राइट. So in this case also when I'm joining it with the midpoints, रेक्टेंगल के केस में अगर मैं any internal point, if I take any internal point and I join it with the midpoints, right, तो क्या यही प्रॉपर्टी रेक्टेंगल के केस में भी चलेगी क्या? Yes, it will work. Why? Because ये PQRS जो है midpoints हैं, right? अगर if I join all these four figures, so रेक्टेंगल के अंदर मेरे को मिलता है रोम्बस. रेक्टेंगल के अंदर रोम्बस मिलेगा तो रोम्बस में प्रॉपर्टी नंबर 8 चलेगी. यस, A plus B विल बी सेम एज C plus D. और ये सारे एरियाज तो इक्वल है, तो चारों एक कांस्टेंट वैल्यू सब में ऐड होगा. देन यू सी दैट कि ये पूरा एरिया A1, ये पूरा एरिया A2, A3, A4 विल बी इक्वल, राइट. सो द सेम प्रॉपर्टी विल बी एप्लीकेबल फॉर रेक्टेंगल ऑल्सो. एंड बिकॉज नाउ यू कैन जनरलाइज इट कि इनको प्रूव करने के लिए जो मेन प्रॉपर्टी है वो ये है कि मिड पॉइंट ज्वाइन करने से इन चारों में से कोई एक फिगर बनना चाहिए और वो सारा फिगर बन रहा है. So can I say that A1 plus A2 will be equal to A3 plus A4 will be applicable for each of these figures, right? So midpoint को any random point when joined with the midpoints, तो जो चार parts बनेंगे, right? Sorry, any point when taken, right? Any random point when taken inside the figure when joined with the midpoints, तो ये चार parts जो बनने वाले हैं इनका summation of opposite areas, summation of opposites A1 plus A2 will be same as A3 plus A4. This is a property which is applicable in all four figures, right? This was property number 9. Let's move on to now property number 10, everybody. So guys, in the 10th number property, we are going to discuss figure formed by the four angle bisector of the figure. In the previous property number 7, we discussed, in the property number 6, we discussed the figure formed by joining the midpoints of the side. इन सभी फिगर के midpoints को join करने से जो फिगर होगा उसको हम क्या बोलेंगे? We have covered it कि पैरेललोग्राम में पैरेललोग्राम बनता है, रेक्टेंगल में रोम्बस, रोम्बस में रेक्टेंगल एंड स्क्वायर के अंदर स्क्वायर. But now here in this property number 9, property number 10, we are going to discuss the figure formed by the four angle bisector of the figure. So if I draw all the four angles bisector of these four quadrilateral, then with the intersection of the four angle bisectors, the figure that will be formed inside the figure will be called as what figure? This is what we are going to discuss. So angle bisector से बचो, angle bisector से हमें ये देखना है कि कौन सा figure बनेगा. So in case of parallelogram, right, if I draw all the four angle bisector of the parallelogram, we know that in a parallelogram, angle bisectors, diagonals are not the angle bisector. So let's say that this is vertex A, B, C and D. Now let's say this is my angle bisector of angle A, the angle bisector of B, right? Let's draw the angle bisector of B. So when angle bisector of B will be drawn, it will be meeting at some point with the angle bisector of A. So angle bisector of A and angle bisector of B will definitely be meeting at a point. Similarly, angle bisector of D and angle bisector of C will also be meeting at a point. So you see that with the four angle bisectors of the parallelogram, you can see a figure being formed inside. So this is what we have to find out, that what this figure will be called as. A figure को हम क्या बोलेंगे? PQRS जो होगा, what will it be? Normal quadrilateral, या फिर ये parallelogram होगा, या rectangle होगा, या rhombus होगा? What will be this figure? This is what we need to find out. So PQRS, right? See that. This is a very important property, guys. Now listen everybody. Look at this figure carefully. We know that in a parallelogram, opposite angles are equal. Parallelogram के अंदर opposite angles equal होते हैं. This is a property number 5 that we have covered. So if I'm saying that this angle is alpha and this angle is alpha because this is a angle bisector, and this complete angle will be same as the opposite angle because in parallelogram opposite angles are equal. So can I say this will also be alpha and this will also be alpha? Similarly, if I'm saying that this is beta and this is beta, why? Because in angle bisector this is 2 beta, so this whole angle will also be 2 beta, so this will also be beta, this will also be beta. Now you see that, look at the triangle ASB and DQC. I want all of you to look at the triangle ASB and the triangle CQD. You see that CQ, yes, and the triangle CQD. All right, ASB and triangle CQD and the triangle CQD. You see that this angle alpha is same as this angle beta is same as this angle beta. So two angles are equal. Third angle will automatically get equal. So can I say that both of these two triangles are similar? Triangle ASB, and also you see that the opposite length are equal in parallelogram. So triangle ASB is congruent with the triangle CQD. Both of these two triangles are congruent. If both of these two triangles are congruent, can I say the side opposite to alpha, that is SB, will have the same length as the side opposite to this angle alpha, that means DQ. Therefore, can I say SB will be same as DQ? Now SB is same as DQ, guys. This length is same as this length DQ. Also, I want all of you to look at the triangle APD, guys. Look at the triangle APD and look at the triangle CRB. Look at the triangle CRB. If you look at these two triangles carefully, these two sides are parallel and equal. This is alpha, this is beta, this is alpha, this is beta. That means both of these two triangles are also congruent with the property of angle side angle. This was also congruent because of angle side angle rule. Two angles and one side is same. In this case also we have proved that two angles and one side is same. So this triangle is also congruent. So can I say the side opposite to alpha, that means DP, will be same as side opposite to alpha in this triangle, which is BR. DP will be same as BR. Now when you subtract these two equations, you see that SB minus, you see that SB minus, if I subtract BR from SB minus BR will be same as DQ minus DP, will be same as DQ minus DP, right? So see that what I'm doing is, this whole length is same as this whole length and this length is same as this length. So can I say that both of these two lengths will be equal? Can I say that SP would be, now in this case SB minus BR will be SR, and that will be same as DQ minus DP, that is PQ. SR is same as PQ. In the same way, you can also prove that this length is same as this length and this length is same as this length is same as this length, right? So you can also prove that SP will also be equal to RQ, right? And SP will also be equal to RQ. Now we have proved that opposite lengths are parallel and equal, right? Of these two opposite sides are definitely equal, right? We have just proved it. Now, so what will be this figure? Now, if I have to name the figure PQRS, are the four sides equal? No, all four sides are not equal. Opposite sides are equal, right? It is not proven that this length is same as this length. This is not something that we have proved, right? Sorry, this length is not same as this length. What we have proved is this length is same as this length and this length is same as this length. Therefore, triangle A, this opposite sides are equal. This is something that we have proved. And now you can see that what is alpha plus beta here? You see that alpha plus beta, we know that summation of two adjacent angle, 2 alpha plus 2 beta, right? 2 times of alpha plus beta is equal to 180 degree. That's again a property that we have discussed in the first part, right? Summation of two adjacent angle is 180 degree. So can I say that alpha plus beta will be 90 degree? Now, if alpha plus beta is 90 degree, that means summation of these two angles are equal to 90 degree. So can I say this angle will also be 90? And if this angle is 90, can I say that this angle will also be 90? Similarly, you can prove that all of these internal angle of the figure PQRS are at 90 degree. So PQRS is a figure where opposite sides are equal and all the angles are at 90 degree. So automatically the opposite sides becomes parallel because all the angles are same as 90 degree. Now tell me, what do you call this figure PQRS where I'm saying that opposite sides are equal and all of these angles are at 90 degree? So you will call PQRS as a rectangle here. Right? So keep this in mind when you join the point of intersection. When you join all the four angle, the figure formed by the four angle bisector of the figure of the parallelogram will be called as a rectangle, right? So PQR here will be called as rectangle. Keep this in mind. Very, very important property. You might get a direct question on it, or you might have to use this property in some question, right? Now let's talk about rectangle here. Now, what is the case of rectangle? You see that if I join similar to, we know that the diagonals are not the angle bisector in rectangle. We have already proved in the previous property. So if I draw all the four diagonals of rectangle, so you see that this diagonal, not diagonal, if I draw all the four angle bisector of the rectangle, this angle bisector will definitely meet at this point. There will be this angle bisector will definitely meet with this angle bisector. Now this figure PQRS, we are supposed to find out what will be the shape of PQRS. This is what we need to prove. Very simple. Again, exactly in a similar way that we have proved in a parallelogram, you will be having a rectangle inside the figure. Exactly in a similar way, you can also find out what this figure PQRS will be called as. Now you see that in this length, right, similar to this, guys, right, A, B, C, D, you can easily prove that. You see that in A, B, C, D, this triangle is definitely congruent to this triangle, right? Now I'll not write it down again because we are following the same concept that we have used in the case of parallelogram. Opposite sides are equal, right? This is alpha, this is alpha, right? This will also be alpha, this will also be alpha. This is beta, this is beta, this is beta, this is beta, right? Angle bisectors and opposite angles will be equal. And because you see that in a rectangle, the complete angle is of 90 degree. Now, if complete angle is of 90 degree, can I say that all of these angles are of 45 degree? So when I'm drawing the angle bisector in the rectangle, these angles will be exactly equal to 45 degrees. So all of these angles are 45 degrees. So you don't have to prove anything here. It's already proven here that this is 45, this is 45. So can I say this complete length will be equal if both of these two sides are equal? And we know that this triangle, right, CQB is congruent with DSA. Now if these two triangles are congruent, length of this will be same as length of this, right? Length of this will be same as length of this. So, and this whole length is same as this whole length, right? So if this DP, you see that DP is equal to PC here. The length of DP is same as PC. Why? Because both of these two angles are equal to 45 degree. If two angles are equal, the sides length will have to be equal. And also, because these two triangles are congruent, exactly in the same way we have proved here, these two lengths are equal. So if the same size is cut from both of these two adjacent sides will also come equal. And similarly, these two sides will also come equal, right? So you see that here, in this rectangle, all the four sides will be of same length. चारों की चारों साइड जो आएंगी सेम आएंगी. इसमें फोर की फोर साइड सेम नहीं आ रही थी. And because this plus this is alpha plus beta combine, alpha plus beta combine is 90 degree. So this angle will also be 90. This angle will also be 90. So see that in a rectangle with four angle bisector, that the figure that you're getting have all the four sides equal. And if it has all the four sides equal, also all the angles are equal to 90 degree, which is very, very easy to prove because these two angles are of 90, so this will be 90, so angle opposite to this will also be 90. Alpha plus beta is 90, so this is also 90. So all the four angles are 90 and all the four sides are equal. So tell me, with the four angle bisector of the rectangle, the figure inside that you will be having would be a square, right? So in a rectangle with the four angle bisector, right, the PQRS, the figure formed inside the rectangle with the four angle bisector will be PQRS, and this will be called as a square, right? This will be called as a square. So in parallelogram we have rectangle, in rectangle we have a square. Okay. What about rhombus? What will be the figure formed with the rhombus? See that we know that in a rhombus, if I draw the angle bisector, right, remember the previous property number 3 or 4, I guess. In rhombus, the diagonal itself are the angle bisector, right? This is an angle bisector and this will also be the angle bisector, right? So will there be any figure you will be forming in the rhombus with the four angle bisector, which are angle bisector itself are diagonals, right, in rhombus. So there is no figure formed with the rhombus, right? So when you draw four angle bisector of rhombus, and because in rhombus diagonal itself are the angle bisector, so there is no figure getting formed. Similarly in square, diagonals are the angle bisector itself, right? Square में भी जो diagonals होते हैं वो angle bisectors होते हैं, right? So therefore there will not be any figure that you will be forming with a four angle bisector in square. So this again an easy one. In parallelogram you will be having a rectangle, and in rectangle you will be having a square, right? This was our property number 10. Now look at the property number 11 for all of these figures. Relationship between the diagonals and the side length. So in a parallelogram, you see that if I have this A, B, C, D, what is the relationship between the diagonals and the sides of the parallelogram, right? Very important property and very easy one also. So if I have to write down the length of the diagonal in terms of the sides of the parallelogram, how will you prove it? See that if I say that this angle is theta, now for this you need to apply the cosine rule here. If I apply the cosine rule in the triangle ABC, look at the triangle ABC and apply the cosine rule. Cosine rule says that square of AC square will be equal to AB square plus BC square minus 2 times of AB into BC into cos theta, right? This is AC square, right? And now also if this angle is theta, we know that summation of two adjacent angle is 180 in a parallelogram, so this angle will be 180 minus theta. If this is 180 minus theta, then you see that the length of BD square will be equal to AB square plus AD square minus 2 times of AB multiplied by AD cos 180 minus theta. Cos 180 minus theta, right? So if I add them up, you see that AC square plus BD square will be equal to AB square plus AB square is 2 times of AB square, right? 2 times of AB square. And we know that the length of BC is same as length of AD, so BC square plus AD square can also be written as 2 times of BC square, 2 can be taken common. And this is what you are left with now. Minus 2AB cos 2AB into BC cos theta minus 2 times of AB multiplied by AD. Now AD length is same as BC, opposite length are parallel and equal. AB multiplied by BC into cos 180 minus theta. You see that you need to know the basics of trigonometry here. This cos 180 minus theta is the second quadrant. In the second quadrant, only sine and cosecant are positive. Cos theta is negative. So cos 180 minus theta will be written as minus cos theta. So minus and minus will become plus. And now you see that both of these two terms are exactly equal. So this will get cancelled. And the property finally you can write down which define a relationship between the diagonals and the sides of the parallelogram. So parallelogram or sides के बीच में जो relation बनेगा in case of parallelogram is sum of squares of the diagonal AC square plus BD square will be equal to 2 times of the square of adjacent sides, summation of squares of adjacent sides. AC square plus BD square will be equal to 2 times of AB square plus 2 times of BC square. Now, this you see that while I was proving this property, the main concept that I was using, which was proving this one, was that the summation of adjacent angle is 180 degree. क्या सभी में summation of adjacent angle 180 होता है? Yes. So can I say this property which states that sum of the squares of diagonal is equal to 2 times of the sum of the squares of the sides will be applicable in all of these 4 figures. So one property which is applicable for all 4. Keep this in mind. The same can also be used for rhombus, same can also be used for rectangle, and rectangle square में तो वैसे भी टेंशन नहीं है because सारे angles 90 degree के Pythagoras theorem लगाओगे तब भी ये prove हो जाएगा, right? So keep this in mind. The property number 11, which will work for all 4, is sum of squares of diagonal will be equal to 2 times of the sum of the squares of adjacent sides. Looking at the property number 12 now, area of the figure found by joining the midpoints of the sides, right? Again, a very important property, that when you join the midpoints of the sides, the area that you will be, the figure that you will be forming will be having the area in terms of the whole figure. In fact, this is a property which is not just applicable for all of these 4 figures. In fact, it is applicable for any type of quadrilateral, right? I'm not taking any parallelogram, rectangle, rhombus and square. I'm taking any random quadrilateral, right? Let's talk about this quadrilateral, which is not a parallelogram, rectangle, rhombus or square. Any random quadrilateral, you see that A, B, C, D. Now, if I join the midpoints of this figure, if I join the midpoint of this figure, let's draw the midpoints here, right? P, Q, R, S. This is P, this is Q, this is R, and this is S, right? P, Q, R, S is a figure formed by joining the midpoints. Now, very easy, guys. Listen, everybody. If I draw the diagonal AC, now P is a midpoint. Keep this in mind. Q is also a midpoint. R is also a midpoint. S is also a midpoint. If I join the line A to C. Now, if I join the line A to C, look at this triangle ABQ. P is a midpoint. Q is a midpoint. Line joining the midpoint will be parallel to the diagonal. Now this line is parallel to diagonal and the length of PQ will be half of AC. Similarly, SR will be parallel to this and SR is going to be parallel to this. The length of SR will be half of AC. Right? Similarly, RQ will be, R is a midpoint of this, Q is a midpoint of this. So if I draw another diagonal, the length of RQ will be half of BD. I'm not drawing the diagonal because the figure will look complex. And SP will be half of BD, right? So SP is BD by 2, right? Also, you see that using the midpoint theorem, can I say, if I'm saying that, let's say area of triangle ACB, assuming that area of triangle ACB is A, and because this length is half of this length, and this length is parallel to this length, with midpoint theorem, I can say that area of this figure will be 1/4 of the whole triangle figure, right? So triangle ACB area is, let's say, A. So can I say this figure area will be equal to A by 4? Let me use a different color here, right? So this area of this small triangle in the corner will be A by 4. Similarly, this triangle is also similar to this triangle. So this area, using the midpoint theorem, will be A by 4. Two triangles are similar. The square of side ratio will be the area ratio. Now you can see that this length is half of this length. So area will be 1/4 of this whole area, right? Now let's assume that triangle CBD has an area of B. Now what is CBD? Now just image, let's draw the diagonal here, right? Now CBD, let's say that CBD area is B. Okay, I have assumed that ACB area as A. So this is A upon 4. Let's assume that DAC area. Let's say that triangle DAC area is B. So this will be B by 4, not A by 4, right? Let me correct it here, because this is any random quadrilateral. So I cannot say that area of this triangle, that means ADC will be same as area of this triangle ACB, right? They can be different because I'm taking any random quadrilateral. So if I'm saying that area of triangle DAC is B, so this small triangle will be having an area of B by 4, okay? Now CBD, if I look at the triangle CBD, right? So let's not draw the diagonal. CBD, this is just assume a diagonal coming from D to B. A triangle CBD area, let's say, is equal to C. So can I say this area CRQ, RQ will be parallel to BD, same midpoint theorem. This length will be half of DB, will tell me that this area will be 1/4 of this whole triangle area C by 4, right? And similarly, now let's assume that triangle DAB area is equal to D. So triangle DBA area is D, so this small figure will be having the area of D by 4, right? So see that now, you see that this, or if I add them up, the complete quadrilateral, if I have to find out the area of the complete quadrilateral ABCD, this will be equal to, now when I'm adding this plus this, right, this is equal to A plus B. This is the area, which is also same as area of triangle CBD plus area of triangle ADB. This is also same as C plus D, right? So A plus B here is same as C plus D. Now, can I say that? Now if I add the area of these 4 corner triangles, the corner triangles will have the area of A plus B plus C plus D upon 4. And because A plus B is same as C plus D, so can I say this is 2 times of A plus B upon 4? This can cancel on 2, so this is A plus B upon 2. So we get to know that the 4 corner triangles have the area equal to half of A plus B, which is the whole ABCD quadrilateral. So can I say the remaining portion, which is this quadrilateral PQRS, will also be half of A plus B by 2 or half of C plus D by 2, which means the figure formed by joining the midpoints of any quadrilateral, not just parallelogram, rectangle, sphere and rhombus, in fact any quadrilateral which is made of 4 sides, right? Obviously quadrilateral is made of 4 sides. The figure that you will be forming inside it by joining the midpoints will have the area equal to half of the whole quadrilateral ABCD, right? So in fact, this is a property which is not just valid for parallelogram, rectangle, rhombus and sphere. It is also valid for trapezium. It is also valid for isosceles trapezium or cyclic quadrilateral or any other quadrilateral, right? Where even all 4 sides are not equal and parallel, because we are not using any parallel thing here, right? We are applying the midpoint theorem that joining the midpoint of this side with this side will definitely be make it parallel to AC. That's a basic midpoint theorem, and I explained to you in the part 1 also. So with we are using the midpoint theorem, and if I'm taking the midpoints of all of these figures, right, so the is area will be half of, right, if this is ABCD, the area of this figure will be equal to half of ABCD, quadrilateral half of ABCD area, right? Same is true for rectangle, rhombus, sphere. In fact, it is true for all quadrilateral. So we have done 12 properties with respect to each of these figures, which helps us in covering 48 quadrilateral. And also, when you are doing these properties for parallelly for all of these 4 quadrilateral, your understanding about these properties gets very improved. And if I'm doing a separate chapter for parallelogram, then a separate chapter for rectangle, then separate sphere, then separate rhombus, it makes it very difficult, and you'll be cramming 48 such properties and you'll get confused. So this is very unique and best method to understand your complete quadrilateral chapter, which I have covered in 2 parts. I hope you liked the video, and this is a very important video, helpful for all the MBA entrance exams and other MBA entrance exams, along with government job exams like CDS and SSC CGL, and students also preparing for IPMAT can refer to this video. Thank you so much for watching the video, and subscribe to the channel, share it with all of your friends. That will really motivate me to put some more content on the video on the channel. And don't forget to click on the bell icon to get the notification of the classes and the live classes and the videos that I'll be uploading. Thank you so much. Please subscribe and share. Thanks a lot.